and bonding worksheet. Okay, so for this first one, it says drag the ions around to form balanced ionic bonds. And you might be like, I don't even know what that means. So that's what I'm going to show you. Also, let's look at this hint. It says, for now, match ions with equal but opposite charges. So what do I mean by equal but opposite? So I would say 2 equals 2, right? Those are equal. But if I want to make them opposite, I want this one to be a positive 2, or just, regular 2. And this side over here to be negative 2. So now, this is not true anymore, right? 2 does not equal negative 2, but these are opposite, right? Okay, so they're not equal, but they are opposite. All right, so let's look at what this means. So let's take one of my atoms here, like say maybe Na. So Na has a +1 charge. If I look at my periodic table, Na is right here. It is in my group 1 area right there. So group 1, they have a +1 charge. So it has a +1. So that means I need to find something that has a -1 charge. And if I look around, I've got another +1 here. I've got a -2. Here's a -1. And there's also a -1 up here. So you could choose either of these, actually. Just for fun, I will choose the Br. So we have Na and Br. So then, yeah, you got to just combine the other, make 2 more pairs using the same kind of logic there with getting equal but opposite charges. And same thing here. Looks like I didn't re-scramble this. All right, so there we go. This is definitely not how it was. Okay, so it says drag the hydrogen cations around to balance the charge of each of the oxygen anions. You'll have some left over. So these blue guys are my oxygen anions. We can tell they're oxygen because it says O, and we can tell they're anions because they're 2-, and so they have negative charges. Negative charges means anions. So we have minus charges there. What I want to do is figure out how many of my little plus charges are going to get attracted to this, because remember, opposites attract. Plus and minus are going to attract each other until they're balanced out. So if I have 2- here, I need to have 2 pluses, okay? And so I'm going to do some little math here to show you my logic. I have 2 oxygens. Sorry, no. I have 2 hydrogens. And each hydrogen, the charge is +1, right? So that's our H plus. And so I need to think, what is 2 times +1? Now, don't let this little plus sign confuse you. I'm just trying to make it clear that this is not a -1. So 2 times 1 would be, 2. And that's what I need because I have 1 oxygen that's 2-, and so it has a -2 charge. Well, what's 1 times -2? -2, okay? And then look at that. 2 and -2 equal but opposite, just like we had before. But the other thing you can check is if I take 2 and I subtract 2, I get 0. So we always want our molecules to end up with a total charge of 0. And that's kind of a good way of checking that we have done this correct. So we have done that. Let's go ahead. Oops, wrong tool, Mr. Schober. Let's see. Undo that. All right, I'm not going to undo that. I'll just straight up erase it with the eraser tool. And there we go. Okay, now back to my mouse. Now I can drag these guys around and make another H2O molecule there. And we'll see what that means in just a minute. And yeah, I do have some leftovers. So that was just there to, confuse you. So maybe you thought you needed to put like 4 on each one or something, but don't do that because that's wrong. That would be something different, not H2O. All right, so use your knowledge of common ions to decide how many Cl- ions would be needed to balance the following cations. Use the pen or text tool to write your answers next to the cations. Okay, so first of all, what's the charge on a Cl- ion? Well, it's -1, right? It says that right in the name. So we need to figure out how many of these would balance out with a -1 charge. Or how many Cl's I would need to balance out the charges of these. So if I look at Li, Li is here also in group 1. And so group 1, we know, has a +1 charge. So if I have a +1 Li and a -1 Cl, well, that's going to be pretty easy to balance out because they they have the same chart or equal but opposite charges, right? So let me drag my text box to right where I want it. Okay, and so I just need to put a 1 in there. I think my text is actually too big, so I'm going to make it a little bit smaller. Okay, good. Now, hit enter twice, and that will get me down ready to talk about B, which is boron. So I look at my periodic table, and boron is right here, number 5. Excuse me, I'm going blind here. Number 5, but it is in group 13. And I know that if it is in group 13, its charge is +3. And so maybe we need to do some math over here. And so you can do this on scratch paper, or you can even do it on here with the drawing tool if you need to. But so boron, so we're talking about boron. It has a +3 charge. And I'm just going to have one of those. So now what is 1 times +3? Well, that's just 3, right? Okay, then if I'm talking about the Cl, we know Cl has a -1 charge. So what could I multiply times -1 to get the equal but opposite to 3? Okay, so we got 2 questions to ask ourselves here. First of all, what is equal but opposite to 3? Well, that's going to be -3. And then I got to think, okay, well, -1 times what equals 3? And so that would just be 3, okay? And so that means, and I could do my math here. Yes, that comes out to be 0. So we are happy that we did our chemistry right. That's supposed to be a smiley face. Oh my gosh. There's kind of well, whatever, just not a smiley face. It's just a 0 because I can't draw that detailed with this. So there we go. That's that. So we need 3 Cl ions. And so I could just go back to my text box, click right there, and put a 3. Now, Na, we already talked about it. We know it's a +1 charge. We know that Cl is a -1 charge. We know if they have the same equal but opposite charges already, we're good to go. Just need 1 of each. Okay? So that's kind of the thinking that we're doing. You guys can finish Mg, Al, and K. And let's do the next one. So these ones are kind of similar, but now we're talking about how many H+ cations would be needed to balance the following anions. So H+ has a charge of +1. That's kind of clear from what it says, just +1, or just plus means +1. And so we need to figure out what is the charge of fluorine, or F. So what I'm going to do is get this thing situated again and go over here. F is in group 17, which means its charge is going to be -1. And so if I have a -1 from my, this guy's a -1, and I have a +1 from H, well, those balance out, right? So that's an easy one. That's one of the simple ones where they have the same charge, so I just need 1 of each. Let's look now. Maybe I didn't. Maybe I made my text too small. There we go. Let's look at N. So N is right here. It's in group 15. So its charge would be -3. And so let's do our little math thing again. And I think you guys will probably get the hang of this. But I have -3, and I only have 1 nitrogen. Well, we know this is actually the same math as before. 1 times -3 equals -3. So that was for my, oops, not for F. That was for my N. What I was going to say, though, is I think you guys can probably do this math in your head. It's pretty easy, but I'm just writing it out to show you my thinking. Then for H, we know that the charge is +1. And we don't know how many, but we know that we need to have equal but opposite to -3. So what would be equal but opposite to -3? +3. And what could I multiply times +1 to give me +3? Just a 3, right? 1 times 3 is 3. So that's really pretty easy math, right? And of course, this equals to 0. Let's try my smiley face again. That's a little bit better. Okay, so we are happy because we got it figured out. Now I can go back over here and type in right here. So N is going to be, I need 3 of them. I need 3 of the H's, right? So basically what you're doing is typing in the number of H's you would need to balance these out. So you can go ahead and finish with S, B, R, C, and Cl. It's pretty much the same idea. And let's go look at our next page.